Now here we see how to find the range of a given function. Typically we can follow this particular procedure given here. Firstly, we consider y equal to the given function f of x, right? So we express y as the given expression of the function. Then we rearrange the above equation in the form x equal to g of y. That means we now express x in terms of y by suitable rearrangements. And lastly, the set of all the possible values of y for which the x on the left hand side exists is nothing but the range of the given function, right? Now for some of the questions we may have slightly different approach, that is we can develop a logic based on different lines. So as an example, see the note at the end, that is if you want to find the range of say a quadratic expression, then that can be found by completing the square also, that is not necessarily by following the procedure given above, but we can also complete the square and get the range, which might prove to be a faster approach. So let us solve few questions based on finding the range. Here we have to find the range of the function given as x square plus 2x plus 3. Now we'll solve this by both of the approaches, that is by first approach is by assuming y is equal to the function, that is nothing but x square plus 2x plus 3. Now since we have to solve this in a way that we have to express x in terms of y, so therefore let's visualize this particular equation as shown here, which is a quadratic in x. So 3 minus y will be treated as a constant term from the perspective of x. Now to calculate x, we use the well-known quadratic formula, that is minus b plus or minus b square minus 4ac. So I write the formula here, divided by 2. So on expanding and rearranging inside the square root, we have 4y minus 8 whole divided by 2. So therefore if you take 4 common out of the square root, it will become 2 outside, and we still have y minus 2 inside the root. So therefore finally we get x as, cancelling 2, we have minus 1 plus or minus root of y minus 2. So now if you observe, to have some meaningful value of x on left hand side, we must have the expression inside the square root to be non-negative. So that means we must have y minus 2 greater than or equal to 0. That means y must be greater than or equal to 2. And y is nothing but the value of the given expression, which is nothing but the range. So therefore range is nothing but the interval from 2 to positive infinity, including 2, right? So that is the range of the given function. Now let's see how we can get the same range by slightly different approach, that is by completing the square. So that is, we can break the constant term 3 as 1 plus 2, so that the first portion becomes a perfect square, that is x plus 1 the whole square plus 2. Now we know that the square of any real quantity is always non-negative, so the least value of this will be 0 and the maximum value will be infinity, isn't it? So if you add 2 to this particular value in the interval 0 to infinity, that will finally be an expression whose minimum value is 2 and the maximum value is still infinity. So that is how we derive the same range as we had obtained by the previous approach, right? So that is the answer of this question. Now let's see another question. Here we have to find the range of the function given by 1 upon 2 cos x minus 1, right? Now the moment we see a denominator, we should keep in mind that the value of the denominator must not be equal to 0. right? So somewhere we have to remember this particular restriction. Now to find the range we follow slightly different technique, that is we start from the term cos x because it's a variable term, that is it can have the value lying between -1 to 1 as we know, right? That's the range of cosine function. Now what do we do is we construct the given expression on right hand side using this starting inequality, right? So we see that there is a factor of 2, so therefore if we multiply throughout by 2 we will get -2 less than or equal to 2 cos x, which is less than or equal to 2. Next we have to also subtract 1. So if we subtract 1 throughout the inequality we will get -3 less than or equal to 2 cos x minus 1 less than or equal to 1, right? So that means the expression 2 cos x minus 1 can lie anywhere between -3 and 1. But now if we club that with the fact which we have already discovered, that is although this expression can lie between -3 to 1, it should not be equal to 0, isn't it? So that means we have to consider a break in the given interval, that is, see, the first part is either -3 less than or equal to 2 cos x minus 1 less than 0, isn't it? Here we cannot have the equality for 0, that is what we have to avoid. Or other possibility is that 0 less than 2 cos x minus 1 less than or equal to 1. So now we just want to skip the point 0 and therefore it breaks the given inequality as two different parts. Now if you see, lastly we have to take the reciprocal, isn't it? So when we take the reciprocal, here we observe that in the first case the required expression is entirely negative, that is it lies between -3 and 0. So therefore whenever we take the reciprocal, what will happen is on one end it will have minus infinity because it is going, the expression is going up to 0. So on one end we will have minus infinity and on the other end we will have reciprocal of the smallest term in the original inequality. So that is nothing but -1/3. Okay. So we have found one possible branch or one possible set of values of the function. Or now in the second case also we have to take the reciprocal. Now here we see that the quantity 2 cos x minus 1 is positive because it lies between 0 and 1. So here also we take the reciprocal and have 1 upon 2 cos x minus 1. Now when we take the reciprocal, it will lie anywhere between 1 and infinity, which is obvious from the given numbers. So therefore this is the another possibility about the value of the expression of the given function. So therefore if you want to club and write as a kind of union of two sets, so therefore range is nothing but the first set is minus infinity to -1/3 including -1/3, or the second set is 1 to infinity including 1, right? So that's the range of the function. Let's go ahead and solve one more question. Find the range of f of x equal to log of 5 minus 4x minus x square to the base 3. Now here we see that the logarithmic function is given and the base is a positive number greater than 1. Okay, so we keep that in mind. Let us write the expression of the function. Here we can see that we can complete a quadratic, that is complete the square in the given quadratic expression, right? So to do that, let us collect the terms so that the quadratic term is positive. So here we have x square plus 4x written as positive inside the bracket which is outside negative, so that we can further write this as 5 minus. Now to complete the square we must add 4, right? We must add 4 inside the bracket. So if we add 4 inside the bracket, then we have to also add 4 outside the bracket. So therefore that gives us plus 4 outside. So that further we have log to the base 3. 5 plus 4 is 9, right? So therefore here we have now we can write it as a square, that is x plus 2 the whole square to the base 3. Now we observe that log is defined only when that particular quantity is a positive number, isn't it? So therefore we have 9 minus x plus 2 the whole square must be a positive number. But we observe that this particular term, the second term, that is a square of a real expression. So minimum it will have the value as 0. And if this expression is minimum 0, the subtraction of that quantity from 9 will be maximum 9 only. Alright. So therefore, although we have this particular entire LHS to be greater than 0, it has the upper bound, that is maximum it can be 9. So therefore, writing that we have also 9 minus x plus 2 the whole square should be less than 9, or in fact we may consider the equality also here. So in other words, if we want to club, we can write that 0 less than 9 minus x plus 2 the whole square less than or equal to 9. So therefore if we want to take the log, now final step is log, because we have the logarithmic term present in the function. So therefore if we take the log, you know that theoretically log 0 will approach to minus infinity. So therefore log of 9 minus x plus 2 the whole square to the base 9 is less than or equal to it is to the base 3. So let me just do that small correction quickly. Log is taken to the base 3, and here will be last term is log 9 to the base 3, right? So therefore minus infinity less than log 3 into bracket 9 minus x plus 2 the whole square, which is nothing but the given expression, less than or equal to, we know that log 3 to the base log 9 to the base 3 will be 2. So therefore finally the required function lies between minus infinity and 2. So therefore to write the range we will have minus infinity to 2, and it is closed at 2 because the value 2 is also a possible value. So that's the range of the given function.